Welcome to the Explainer. So let's just dive right in, shall we? Today, we are cracking a secret language, one that's literally written in plain sight on the side of basically every piece of heavy machinery out there. You know, if you've ever walked past a massive earth mover or maybe a front-end loader, and you found yourself wondering what on earth all those random letters and numbers stamped on the rubber actually mean, well, you are in the exact right place. We are going to completely decode the DNA of off-the-road tires. And I'll tell you right now, the consequences we're dealing with here are absolutely massive. We aren't just talking about picking a tire that, looks cool or happens to fit the rim. Slapping the wrong rubber on the dirt or just completely ignoring off the road, or OTR, tire codes, is a critical operational mistake. Doing that can lead to thousands and thousands of dollars in sudden financial losses. Or, far worse, it can create severe safety hazards right on your job site. So the stakes, they are literally as high as they get. So how exactly do we avoid those expensive disasters? Well, here is our roadmap for today. We're going to cover the high stakes of tires, radial versus bias construction, decoding TRA machinery codes, tread depth and strength, and then finally reading the full sidewall. Starting things off with Section 1, the high stakes of tires and why they are way beyond decoration. The absolute core philosophy of OTR tires really just comes down to this. These codes are not decorative. They define the identity and the maximum capabilities of the tire. Understanding them isn't just some friendly suggestion from the manufacturer, right? It's the ultimate guide to the physical limits of your machine. If you try to push a tire beyond its coded identity, well, physics always wins, and the tire's going to fail, plain and simple. Let's move on to Section 2, radial versus bias construction, looking at the inner build. Now, OTR tire size formatting might actually look a lot like your standard car tire at first glance, but a single symbol changes absolutely everything. If you spot the letter R on the sidewall, you are looking at a radial tire, and that indicates a steel structure inside. Radials run cool, they give you way longer tread life, much better fuel efficiency, and they keep heat generation really low. But if you see a simple hyphen instead of an R, that actually indicates a bias, or nylon construction. This uses crisscrossed nylon layers instead of steel. And while bias tires do generate higher heat during high-speed travel, they give you incredibly tough sidewalls. I mean, if your site is covered in jagged, sharp rocks that would just slash a normal tire to ribbons, that bias tire is exactly what you need. All right, Section 3, decoding TRA machinery codes, focusing on the application. Think of this as your core translation matrix. Every single OTR tire has a specific letter code marking exactly where and how it should operate. E is for Earthmover, built for massive machines like scrapers and dump trucks. L is for loader, specifically your front-end loaders and dozers. G stands for motor graders, and C is for compactors, like road rollers. Now here is where operators make some incredibly costly mistakes. If you take an Earthmover tire and put it on a loader, or vice versa, you are practically guaranteeing premature tire failure. It's a disaster waiting to happen. These machines distribute weight and stress in completely different ways, and their tires are highly engineered to match those very specific applications. Moving right along to Section 4, tread depth and strength, pushing the limits. Right after that machinery letter we just talked about, you're going to see a number from 1 to 5. This dictates the exact environment the tire is built to handle. A 1 means smooth. Think of a slick C1 tire used purely for asphalt paving, where you absolutely do not want any tread marks left behind. A 2 gives you standard traction. 3 is your standard rock tire, but when conditions get exceptionally rough out there, you move up to a 4 for deep tread and all the way to a 5 for extra deep tread. To put that into perspective, an L5 loader tire has an incredibly thick, extra deep tread specifically designed to survive in the most punishing, highly abrasive rock conditions imaginable. But hey, tread depth is really only half the battle, right? We also need to know the casing strength. And there's been this fascinating evolutionary leap in how the industry actually rates this. Back in the day, traditional bias tires measured strength using a ply rating, or PR. You'd see something like 24 PR or 32 PR. This literally counted the number of nylon layers packed inside the tire. But as modern radial tires started taking over the industry, well, counting nylon layers didn't make much sense anymore because radials use steel. So the industry shifted gears to the star rating system to measure the casing strength of a radial tire. It's a beautifully simple system. A 1-star tire is designed for your standard low to medium work pressure operations. If you step it up to 2 stars, your casing is equipped for high pressure operations and standard heavy loads. And finally, you have 3 stars. 3-star tires are specially engineered for the absolute most extreme, high-load mining environments on the planet. Like I said, it's elegant. The more stars you see, the higher the pressure and the heavier the load the casing can withstand without blowing out. And that brings us to Section 5, reading the full sidewall and assembling the code. So I've got a question for you. How do we actually put this all together when you're out there in the field? Because let's be honest, it's one thing to understand the theory in an explainer. It is another thing entirely to stare down a massive, dusty, black rubber wall on a live job site and know exactly what it's telling you. Let's put your new knowledge to the test. Let's completely decode a real-world example right now. 26.5 R25 L5 with a 2-star rating. Okay, right away, the 26.5 tells us the tire width in inches. That crucial R sits right in the middle, loudly proclaiming this is a steel radial construction, meaning it's going to run cool and efficient. The 25 is our rim diameter in inches. Then we jump over to the application code, L5. Thanks to what we learned earlier, we know L means it absolutely belongs on a loader, and 5 means it packs an extra deep tread for maximum rock protection. And what about those 2 little stars at the very end? That confirms its casing is rated for high-pressure, heavy-load operations. Just like that, boom, the mystery is completely solved. You know exactly what machine this belongs on, exactly how it's structurally built, and the extreme conditions it's meant to survive. And honestly, that brings us to the end of our explainer. The next step? Well, that is entirely on you. The absolute best way to lock all of this in is through real-world visual engagement. I mean it. Grab a piece of chalk and physically circle those L5 or E4 codes. Grab a tread gauge to physically measure the difference between a standard L3 and a massive extra deep L5. Go read your site's tire DNA today. Bringing this knowledge out of the classroom and actually checking your fleet is exactly how you prevent those $1,000 mistakes and, more importantly, keep your operators safe. So I'll leave you with this final thought. Knowing what you know right now, if you walked your job site today, how many machines do you think are currently running on the completely wrong tires? Thanks so much for joining me on this explainer, and keep learning.